In the previous lecture, we discussed about how to improve the capacity in cellular system. So we have seen that there are mainly three techniques: self-splitting, sectoring, and microcell zone concept. So in the previous lecture, we have seen about the cell splitting, the concept of cell splitting. So and its drawbacks. So we are mainly this improving capacity in cellular system will be helpful in providing the channels or frequencies to more number of subscribers. So coming to sectoring, the co-channel interference in the cellular system may be decreased by replacing a single omnidirectional antenna at the base station by several directional antennas, each radiating with a specified sector. So here in the place of omnidirectional antenna system, which we have done earlier, we are replacing a several directional antennas, each radiating within a specified sector. Okay, by reducing the co-channel interference. So by doing this, we can reduce the co-channel interference also. How we can reduce, we will see in the next slide. So by using directional antennas, a given cell will receive interference and transmit with only fraction of the available co-channel cells. So as what is the here actually happening is, if you are going to use, or if you are using omnidirectional antenna, so it will be radiating isotropic antenna it is, so it will be radiating in 360 degrees direction. So the interference will come from all the 360 degrees direction. So instead of omnidirectional antenna, when we are replacing the directional antenna, what is happening is that only in that direction the interference will occur. So in all the other directions, there will be isolation of the interference of the signal, the co-channel interference. So with this, what happens is that number of co-channel cells which are taking part in the interference will be reduced. So automatically what happens is that the signal reception power will also be increased. We will see that theoretically and practically in the next sessions. The technique for reducing co-channel interference and thus increasing system capacity is done by using directional antennas, and this concept is called as sectoring. Once again, I am repeating, the technique for decreasing co-channel interference and increasing the system capacity. So not only we are decreasing the co-channel interference, we can also increase the system capacity when we are replacing the omnidirectional antenna system with directional antennas. So this concept is called as sectoring concept. So a cell is normally partitioned into 3 180 degrees sectors. Sorry, it is here not there. 3 180 degrees sectors or 6 60 degrees sectors. That is in this way. So a cell, this is a cell, hexagonal cell. Here we are partitioning it into 3 120 degrees sectors. 3 sectors we can decide split. Here coming to the 60 degrees sectoring. Here we are having 60 degrees sectors. 6 cells we are having 60 degrees sectoring. So in this way we are sectoring. So you can see here, this is a cell, center cell. This center, in the first tier, 6 co-channel cells will come into interference, as I have shown in the deriving the formula for character interference ratio for the normal case in an omnidirectional antenna system. So 6 co-channel cells are taking part in the co-channel interference. So here, but as we are using the 180 degrees sectoring, this is 180 degrees sectoring, the interference from this, it will go this direction, this will go this direction, this will go this. So this will go this. So only the interference from these 2 cells, that is back, these 2 cells, there will be interference for this cell. So instead of 6 co-channel cells, now the number of cells are reduced to 2. These 2 cells only are causing the interference for this center cell. So in this way, we can reduce the, like this, you can see here, the radiation pattern also we are showing here. The 5, the frequency with this 5 number, this is the 5, this is 5, this is 5. These are all using the same frequency. And here you can see this cell is having the interference only due to these 2 co-channel cells. Coming to this co-channel cell, the radiation pattern is going this side. This is no way. It is going this direction. This is going this direction. This is going this direction. So the possible interference cells for this cell are only 2 cells, these 2 back cells. So here in the 180 degrees sectoring, we can see the number of co-channels previously which we have assumed as 6, now they are reducing from 6 to 2. So obviously what happens? the co-channel interference reduction factor will be improved. Okay. This is the concept of main concept of sectoring, or we can say that we are replacing the usage of directional antennas instead of omnidirectional antennas. So next, coming to the another concept which is helpful in increasing the capacity of cellular system is microcell zone concept. So here antennas are placed at the outer edges of the cell. You can see here the antennas are placed at the outer edge of the cell. Any channel may be assigned to any zone by the base station. Here we are connecting to the zone selector by using the fiber optic link or microwave or fiber optic link, and then we are connecting it to the base station. Any channel may be assigned to any zone by the base station here. Here the zone selector is there. So mobile is here served by the zone with the strongest signal. The zone which is having the strongest signal, that zone will be given to the mobile. So handoff within a cell. No channel reassignment will be there because we are here assigning the zone itself. Switching the channel to a different zone side, reduce interference. So low power transmitters are employed here. Sectoring increase the number of handoffs. That is, it results in an increased load on switching and controlling. So each of the three zone sites are connected to a single base station and say that here the same radio equipment here. Okay. The antennas are placed at the outer edge of the cell. As a mobile travels in this zone, it will be served by the strongest signal. So there is no situation of handoff. So the handoff problem will be reduced in the case of microcell zone concept because of the zone selected. So the handoff is not required. That is, mobile station retains the same frequency channel. The base station simply switches the channel to a different zone side. So co-channel interference is reduced and thus improves the signal quality. So this is about the microcell zone concept. So these three are the techniques which are helpful in reducing the, in improving the capacity of the cellular system, that is cell splitting, sectoring and microcell zone concept. Thank you.